Okay, so in that day lecture, I talk about the equation of continuity in Klein coordinate equation. Now, today's lecture, I will talk about non-relativistic limit of Klein coordinate equation. So, let us consider Klein coordinate equation for free particle. For the free particle, as we have derived in the earlier lectures. So, yeah, P mu psi is equal to m naught square c square psi, or this equation can be written as also curly square over c square curly t square minus curly square over curly x square plus curly square over curly y square plus curly square over curly z square plus m naught square c square over h cross and whole psi is equal to 0, and let us recall this as equation number 1. Now the wave function for free particle is given as wave function for such a equation can be written as we have discussed in the earlier lecture. This can be written as like this, that psi is equal to exponential plus iota over h cross px p dot x minus et let me call this as equation number 2. So to introduce non-relativistic limit of Klein coordinate equation, let us split wave function into two terms in which one containing rest mass, that is this psi as a function of RT, it can be written as phi RT. Here it should be R, not X. Exponential of minus iota h cross over m naught c square t. That's what. So this containing rest mass term, right? So in a non-relativistic limit, the difference of total energy E of particle and rest mass energy that is m naught c square is small. In other words, I can say that E prime is equal to E, or in other words, I can say that E minus m naught c square is equal to E prime, and let me call this as equation number 3 and this is equation number 4. Here E prime is small in non-relativistic limit. Therefore, E prime is very much less than m naught c square. So let us recall now the time dependent Schrodinger equation, that is iota h cross curly phi over curly t is equal to E prime phi, but here E prime is very much less than m naught c square. That's why I can write down this equation as I h cross curly phi over curly t is equal to E prime phi, and which is further less than equal to m naught c square phi, and let me call this as equation number 5. So let us now calculate. Now we will calculate psi over curly t and curly square psi over curly t square using equation 3, and we will use this later on in equation number 1. So let us now calculate. And use it in equation 1. So now using the value of psi, we can calculate curly psi over curly t, and it is phi curly over curly t into exponential minus iota h cross. This is first function, this is the second function, m naught c square t plus exponential minus iota over h cross m naught c square t and curly phi over curly t. So if we calculate its derivative, it can be written as phi exponential minus iota over h cross m naught c square t, then its derivative again, and its derivative is this minus iota over h cross m naught c square t plus exponential minus iota over h cross m naught c square t and curly phi over curly t. Now this part can be written as phi exponential minus iota over h cross m naught c square t, and it is minus iota h cross m naught c square, means this is the derivative of this one, plus exponential minus iota h cross m naught c square t, and it is curly phi over curly t. This is common in both, so that means this curly psi over curly t, it can be written as curly phi over curly t minus iota m naught c square h cross phi, and outside I can take the exponential term, so I can write on it in this way. Now since iota h cross curly phi over curly t is nearly equal to e prime phi, and which is very much less than m naught c square phi, so therefore keeping in view this term can be ignored. So if I ignore this, then curly psi over curly t, it comes out to be nearly equal to minus iota m naught c square h cross phi, and exponential of minus iota over h cross m naught c square t, right? So that's what we are getting here. So this is curly psi over curly t, and let me call this as equation number 6. Now I will use this part again to calculate the second derivative of a function. So to do that, I will use this part. So to calculate it, curly psi square over curly t square is curly over curly t curly psi over curly t, and let me put its value here. So it is curly over curly t into curly phi over curly t minus iota m naught c square h cross phi, and it is exponential of minus iota h cross m naught c square t, right? That's what we will use it here. So let us apply the product rule here. So when I apply product rule, then I can write down the thing again. So it is equal to first function as it is, and then derivative of second function, plus second as it is, and derivative of first part. Right, I will do it in this way. Therefore, curly square psi over curly t square is equal to, it is curly phi over curly t minus iota m naught c square over h cross phi, right? And its derivative exponential minus iota over h cross m naught c square t, and minus iota over h cross m naught c square, means its derivative again applying chain rule, plus exponential minus iota over h cross m naught c square t curly square phi over curly t square minus iota m naught c square h cross phi. So I can do one thing that yeah, it is this part goes to in multiplication with here, so I can write down this as minus iota over h cross m naught c square curly phi over curly t, and it gets multiplied with it, and when this gets multiplied, then the iota square will be equal to minus 1 and it will be minus, so it is m naught square c4 over h cross square, and phi will be there, and this part is common, this part is common, so it can be taken outside, and here it is plus curly square phi over curly t square and minus iota over h cross m naught c square. Sorry, here I will take its derivative, to it with curly psi over curly t, this should be there. So keeping this in mind, yeah, I can write down it as curly phi over curly t. These two terms looks identical, and outside I can take exponential term minus iota over h cross m naught c square t. Now this term can be ignored, as we have ignored in the earlier equation for deriving curly psi over curly t. In the similar fashion I can ignore this also, keeping in view the m naught c square is very much larger than curly psi over curly t. So now curly square psi over curly t square, this part can be written as minus iota 2m naught c square h cross, and this iota can be okay, I will take it later on outside, and it is m naught square c4 over h cross square, it's phi, sorry, and curly phi over curly t will be here, and outside there is exponential term minus iota over h cross m naught c square t. So therefore curly square psi over curly t square can be written as minus iota 2m naught c square h cross curly phi over curly t plus m naught square c4 over h cross square phi, and it is exponential of just a minute. So it is exponential minus iota over h cross m naught c square t right? So this is the value of curly square psi over curly t square, right? Now what I will do, I will substitute the values of psi, curly psi over curly t and curly square psi over curly t square in equation number 1. So equation number 1 which we have calculated, it is the equation number 1. Curly square psi over curly z square is this one, and is equal to h cross psi. This is the equation number 1. So if I use the values of psi and curly square psi over curly d square here, then this equation will be equal to 1 upon c square, its value will be minus iota 2 m naught c square over h cross curly phi over curly t plus m naught square c4 over h cross square phi, and the exponential of minus iota over h cross m naught c square t. This is the value of this which we have substituted, minus curly square over curly x square, curly square over curly y square, and curly square over curly z square into the value of psi. Psi is phi, exponential minus iota over h cross m naught c square t equal to m naught c square h cross phi exponential minus iota over this into this. That's what we will substitute it here. Now these exponential terms are common, so they will cancel out. So if they will cancel out, then I can write down this as minus iota 2 m naught c square over h cross c square curly phi upon curly t minus m naught square c4 over h cross square into c square. This c square will gets multiplied here, minus curly square over curly x square plus curly square over curly y square, curly square over curly z square, and it is phi is equal to minus m naught square c square over h cross and phi, and this c square will cancel out with it. Now these two are equal and opposite, that's why they will also cancel out, and this c square will cancel out with it. So the equation which I am getting is minus iota 2 m naught over h cross curly phi upon curly t is equal to curly square over curly x square, curly square over curly y square, curly square over curly z square as a phi, because this I have taken towards other side. Now multiplying both sides by minus h cross square by 2m. So if I multiply this by h cross square by 2m, this negative will cancel out. So the equation which we are getting It is minus iota h cross curly phi over curly t is equal to minus h cross square by 2m naught, and it is curly square over curly x square plus curly square over curly y square plus curly square over curly z square, and taking phi here. So this is Schrodinger wave equation for free particle derived using Klein equation and using Klein equation and applied the non-relativistic limit. That's all for this lecture.